Yes, we can.
Okay, so today we're going to take a closer look at History API. It's an API that most of us already use in our everyday lives for building single-page apps, but it's usually hidden under the hood of frameworks and libraries. And we always kind of do the same thing, take a router, add few routes, and fly. That's it. But today I would like to challenge that and yeah, challenge our current state of navigation on web. Um, my name is Clement, and I'm a software engineer at Pratt & Whitney. I'm a drummer and in love with nature. So let's take a closer look at History API. It's quite small. It's placed in a global window object. We have back and forward movement. We can go n steps in each direction if there are sufficient things on the history stack. And we can prevent the default scroll restoration behavior. So we can actually say like, I don't want this page to keep the scroll, and when user navigates back or forward to it, it won't keep that scroll. But then there's a whole another dimension of things we can do. And the first kind of things that opens that all up is the state. It's just a representation of state, and we can put anything in it. We can push it or we can replace it. But what is state anyway? I found a definition in Oxford Dictionary that states that state is the particular condition that someone or something is in at a specific time. So now that we have a basic idea of what state is, let's look at the stack. Stack is just a data structure that lets us push things on top of it, and we can also take them from the top. This figure shows us that stack represents an imaginary user's journey. And first, our user visits the home page and then logs in a login page. And at that moment, we already communicated the login with the backend, and it's time to take the user to the profile page. And we can push profile page on top of their stack. But our user suddenly sees their watch, they realize that it's the end of their shift, and as a good citizen, they actually decide to log out. And we also communicate that with the backend. And since the login page is still just one frame on top of the profile page is on top of the login, we can just pop that. And this is not really how you should implement the login flow, but it can serve as a rough estimation or rough illustration of how history stack works or how any kind of stack works. But let's see how we can call those functions. History stack is something more than a stack because it also has a feature. So we are moving up and down in this stack, and we can call forward and go, or call go with the amount of steps we want to go in the direction of our movement. And now our user is on the settings page. And after they successfully updated their settings, it's time to go back to the profile page. So we can use back or go -1, come back to the profile page. If we provide 0 for the go, we would refresh the page, but the state would be retained. And that also happens when we refresh the app normally. So we still have that state that we wrote into that. We can also push the state, and it's represented just by a basic JS object. That way we can build something more like a router that fits our needs. We can stop using long path names and just give simple names to our screens. So we don't have like first screen in the second menu or something. We can just name it as it is. And then route name is not even necessary with this. It's just representation of, or a minimal representation of state. So we just show it so users can copy it around. And we could also let the next page know where it's sourced. So we could use that for analytics or for traveling back from some inner point of the app. Let's take a look at how to replace that state. When we replace the state, users or nor we can return back to that state. state. So replacing state won't cause a reload, but we can use it to, for example, synchronize the inputs. And after we do a reload, we can take those values back and initialize them in our app, and then the inputs or any other local state will still get those properties. So we won't lose any progress. But most of the things that we've seen are kind of like location, setting the location, and browser takes care of everything for us. So there must be something in hindsight that we forgot about. It's state, like it can be anything. So we can do pretty much anything with it. Let's take a look at how to formulate a state from a simple URL, because it's a perfect example that shows us just like how our URL is basically a structure of things that we define at some other point. So here we're just representing it with a JS object, and I hope this doesn't come as a surprise for anyone. But what happens if we try to mimic browser tabs inside the browser? So we could build a browser inside the inside of our app, with web technologies, and try to imagine a navigation megazord for a moment. Like, what would that mean? Like, what could we lose by doing that? So you can probably imagine that it's powerful, but probably all of you have different ideas of what the implementation would look like, or even how the state would look. So let's try to define it and see where that leads us. So I would like to start by giving it a name. It's a Time Machine 9001, but you could also call it an implementation of tabs inside browser tabs, your choice. Let's define a few things so we can use them later. The first one is entry. Entry is a pair of state and object, state object and URL. We use them all along, like just every page has a state and then it has an URL. So this is already in the browser. But we're gonna abstract that and put those entries in a stack. So we are building our own stack now. And if we take the stack and multiply it a few times, we can build ourselves tabs. And when we have tabs, now we kind of defined like basic structures of what we're going to do. So let's look at some interactions that we would allow with this API. We can push an entry, and we can replace state and pop state. We can also change a tab. And now that we have all this, let's see what properties do we need. First one is current entry that represents where our user is. Second one is the current tab. That's just a number in like which of the stacks we are currently looking at. And then tabs is an array of stacks like we've seen before. So TARDIS and Doctor Who really shows on the inside. So let's see what we can do with this state. First, I'm going to try to represent it with some modified JS. And here we can see that we have an array of tabs, and each tab is just an array with a list of entries. We have current tab, which is 0. And then we have current entry with properties URL and state. It's an entry. And we can take all of that and just put it in stack, and then use it later in a app. But what can we do with it? Like, what did abstracting everything bring us? And how can we use that to actually create the app experience that we want to? It comes to no surprise that we can switch tabs. They're just like regular tabs in the app. And we can navigate between pages, like going forward and backward, as you would expect from a regular page. So this is not like really impressive. So let's see something better. Now, with having all those tabs and current tab, we can switch tabs while keeping their states. So each tab now has their own history stack, and we can go through those stacks. and keep them in place. So when we return to our tab, we'll still get 5 pages that we visited before, and we could go back. Or just like drop the whole stack if we click on the same tab again, so we get to the homepage of that tab. We can even return user input, like we just save it with a replace, and then on load, we can just take it back and render it. And in one of our labs, using this approach, we found out that we could have 4 same forums open at the same time and concurrently editing them, even allowing the refresh for the user. So even after they refresh, they would still get all those inputs that they inputted, and their workflow wouldn't get disturbed. We can stretch that further and do multiple instructions on a single action. So here, for example, we can push another page on another tab, or we can even do that silently, so our users won't even notice. And while doing all that, we still keep the browser's buttons functioning. So you can go click back, 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 or forward in browser and have all that state in even the forum. So I could leave the forum and go back to it, and all the data would still be there. But what if something goes wrong? Well, when we abstracted the whole thing, we got the power of creating our own tools, and we should enable others that can see through the matrix of our mind with tools, so they won't chase us down when something breaks. Here's an example of debugger. It prints the state on every change. It also provides you the line where the action actually started, and then on the top we could see all the state this is, or all the like history stacks that we have in the place. And this was just a demo app that I created to show this concept. And I will post a link to the code, and you could click around to see like how it works, or look into the code to see like what's happening. But the implementation for the whole system is quite small, and then you can use it all across your app. And even if you're using a library like React Router, you can do a quick refactor to just change all usages of that to something else that you've built, and then your app should still work the same as it did before. And we actually implemented this in the project, in the middle of a project, so we had like 30, 40 pages, but we could still quite easily replace all the usages of router. But what really helped us was setting the ESLint rule to prevent developers from using library for doing the routing. So every time you would use a React router, which this thing is built up on top of, but you could build it vanilla, you shouldn't use React router because you already abstracted it. And I would really like to stress that this is just one of possibilities or things that you could do with History API, and it's based solely on my taste and our needs that we had in the project. I'm sure there are tons of other things that you could do with History API, and I will publish links to slides and React Sandbox in the Meetup app, so you could play around with it. I would also like to thank all of you who joined, and Samantha for helping the community grow. If you have any questions, you can just post them to the Meetup event or ping me online. And I would just like to say to all of you, we should live long and prosper, and remember that without sharing, we couldn't be where we are today. Clement out.
Okay, thank you, Clement. I see that there is a question for you.
Okay. Let me stop sharing. Where is the question posted?
So Q&A, you have a action Q&A, and just click on it and you will see open questions.
Okay. Are there any performance concerns when keeping the historic state in different tabs? Maybe an idea of how to work around that. So we didn't find any like issues because the state isn't getting so huge. You're still just putting, you're not putting all the data in, you just put in everything that you would like to retain after a refresh. And even like doing all the actions and everything, you can still split the code in smaller functions, and JS should be like, unless you have 10,000 of entries open in each step, you could be safe. And even that didn't really happen in the void. And is there a limit to the size of that contextual state per tab? I think it's around 400 kilobytes in Mozilla. So I guess that's the hard limit if you want it to work in all the modern browsers.